Okay, in previous lesson we discussed about selective structure if then else. We consider some examples. We discuss about nested selective structures, about short selective statements. Also, we considered multiply selective structure, switch case, and break. And the topic of this lesson will be the loop structures. Of course, you already use these structures on practice, but on lectures we discuss about some details, some theoretical details of these computational structures. We consider some examples that shows you the possibilities of C language. Maybe these possibilities you will never use on practice, but it's very useful very important to understand how it works, how these statements can be used. Well, loop or cycle is a computational structure for repetition of a group of statements several times. These repeated group of statements is usually called loop body. So loop body, the sequence of the statements that should be repeated several times. This group of statements can consist of only one statement or can consist of several statements executed successively. From the point of view of computational structures, this group of statements can be considered as a one sequential structure. In C language, this sequential structure can be organized as a block, as a composed statement. And the main feature of the loop is that it back off to the beginning of the loop body for its repetition when the loop body is ended. So it's jump backwards in general computational scheme of the algorithm. Well, and to organize such repetition, we should write some additional statements in the program. First, any loop includes as its part a condition of loop termination. This condition is checked at every iteration of the loop. And according to the result of checking, secondly, any loop should include one or more variables that are used in this condition. And these variables are usually called control variables or loop counters. These variables is used in condition. And according to these variables, the condition can be changed. Such variables must be initialized before the loop, and the value of these variables should be changed in the loop body. In C language, initialization of control variable can be included in the loop statement or can be done before the loop. According to where the termination condition is placed, all the loops may be divided into two groups. Loops with pre-condition. It means that the condition is placed before loop body, and loop with post conditions. Loop where a condition is placed after loop body. The general scheme of the loop with precondition is placed here on this slide. The loop execution starts with checking the condition. If this condition is true, if it returns yes as a result, then loop body is executed. Loop body again can consist of one or more statements. If there is more than one statement, these statements should be enclosed in figure brackets as a block. When loop body is completed, then we go back to the condition and check it again. If this condition is true again, then we repeat loop body. After that, we come back to the condition, check it again, and only if this condition is false, then the loop execution is stopped. And the program is continued. On this slide, you may see the general scheme of loop with post condition. Post condition means that the condition is placed after loop body. So first we execute a loop body, and after that we check the condition. If this condition is true, then we come back to the beginning of the loop body and execute it again. And after that, we check the condition. If this condition is again true, we come back to the loop body, execute it until this condition becomes false. And only if this condition is false, then the loop execution is terminated and the program is continued. Sometimes loop can be looked as follows. The condition is placed between two parts of loop body. I can say that here's loop with internal termination condition. One part of the loop body is placed before the condition and another part is placed after the condition. First, we execute the part number one of the loop body. After that, we check the condition. If this condition is true, then path number 2 is executed, and path number 1 is repeated, and so on. If this condition is false, then we go out of loop and skip the loop body part number 2. What is the main difference between these two loops? Loop with precondition and loop with postcondition. The main difference is in number of repetitions of loop body. Let's consider the case when the loop condition is false from the very beginning. What happens in this case? If the loop condition is false from the very beginning, the loop body will never execute it, because the condition is false and we go out of the loop. So when we have loop with precondition, it's possible a situation when the loop body will never execute it, will never be executed. Here, when loop is loop with a post condition, in this case, loop body will be executed at least once. Indeed, when we start the loop, first loop body is executed, and only after that we check the condition. And if this condition is false, loop is stopped, but loop body is already executed. Well, in some cases, it's very important to execute a loop body at least once. Well, this is the main difference between loop with a precondition and loop with a post condition. Well, you see that the loops can be divided on these two groups. Loop with precondition, loop with post condition. But from all the loops can be divided into another two groups according to the number of repetitions. There are two completely different situations. In one of them, in first situation, we know exactly how many times loop should be executed. For example, we should repeat some action exactly 10 times. We know that some statements should be repeated this number of 10 times, and that's all. But sometimes in some algorithms, it's impossible to know in advance the number of loop repetitions, because it is determined in the course of loop execution as a result of some computational statements or some user inputs. In this case, loop, we don't know how many times this loop will be repeated. And from this point of view, all the loops can be divided into loops with known number of repetitions and unknown number of repetitions or iterations. In C language, there are three types of loop statements. Two of them describe precondition loops, And the last one is loop with a post condition. Cycles of all the types may be taken for organizing loops with both known and unknown number of repetitions. Our consideration will start from the maybe most simple loop, most simple situation, loop with known number of repetitions. And in C language, the loop for is the most convenient for describing loops with known number of repetitions. The general scheme of loop for is presented here on this slide. For is a keyword. Then, in parentheses, we should write three expressions. Expression number 1, expression number 2, and expression number 3. After that, I should write some expression number 4 that corresponds to body of loop, body 4. Statement body 4 is a statement that contains loop body. Some computational statements that should be repeated several times. What is the meaning of these expressions? Expression number 1 provides for the operations of loop initialization. It is computed only once when the loop is starting. Expression number 2 takes part in checking up of loop termination condition. It's computed before the statement body, before the loop body, and its value is compared with 0. If the value of expression 2 is not 0, so if this expression returns true, the loop body is executed. If the expression 2 returns 0 equals to 0, it means the expression 2 is false. Then loop is considered to be completed. And we take the next statement after loop to continue the program. Expression number 3 is computed at the end of loop, after all operations of the statement body 4. Usually, as a rule, this expression number 3, is used to change the loop control variable, loop count. Well, again, this is a loop body. Expression number 1 is computed only once before loop. Expression number 3 is computed after loop body, and expression number 2 is a loop termination condition. On the diagram, these are the structure of loop 4 can be represented as follows. First, the expression number 1 is executed. After that, expression number 2 is checked, is computed. So this expression corresponds to the condition. If this condition is true, if this condition is not 0, then we execute loop body, and after that expression number 3 is executed. When the expression number 3 is executed, is ended, we come back to the checking of the condition. We compute the expression number 2 again and compare its result with 0. If it's not 0, then we repeat loop body, we repeat the expression, and so on. We come back to the loop condition, and only if the result of the expression number 2 is false, only in the case when the expression number 2 equals to 0, the loop is stopped. And we go to the next statement. Well, this is a general scheme. Now let's consider some examples. These examples are written here in my presentation on the slides, but I think it's better to consider these examples in details in Visual Studio. Well, now let me switch to the Visual Studio and let me write some examples. To organize loop 4, first I should introduce loop variable, loop counter. Usually this loop counter is a variable with the name I. This letter is used just because this is the first letter of the word index. Well, suppose I want to output to the screen first numbers 1, 2, 3, 4, 5 up to 10 numbers. Okay, in this case I should write loop 4. Then the value of the loop counter is 1. First 10 numbers corresponds to the loop condition I smaller or equals 10. And the loop, the rule of changing the loop counter is I++. Well, let me remind you that I want to output to the screen 10 numbers. Okay, let's do it. Cout I. Here in this loop, the loop counter starts from 1 and it will be increased +1, +1, +1 up to 10. Well, let's run this program. Let's check what we will see on the screen. Yes, we will see these numbers, but these numbers follows one after another without space. Okay, let me insert space here. And now let me run this program again. Well, you will see that these numbers now is with a space between it, between these numbers. If I want to output these numbers in a column, I should place here the end of line. In this case, these numbers will be output in one column. One number per one line. 1, 2, 3, 4, 5 up to 10. Well, let's modify this loop and suppose that I want to output to the screen not 10 numbers, but the first n numbers, where n is the variable. In this case, the value of this variable can be assigned by means of assignment statement, but now I should modify the loop condition. Now loop condition is I smaller than n, where n is a given number. If I run this program, I will see on the screen first 20 numbers. If I change the value of n, I will see the corresponding number of numbers on the screen. All 15 numbers. Well, how to modify this program to see on the screen not the numbers, but, for example, the squares of these numbers. Very simple. Let's insert here some computational statement, the square, and in this case, I will see on the screen the sequence of squares 1, 4, 9, 16, 25, and so on. The squares of all the numbers from 1 to 15. Well, the next very important example that I want to show you is a sum of the numbers. How to compute the sum of several numbers. In this case, I should introduce a new variable, sum, and I must assign initial value to this variable. Here in this loop, I should modify this sum on the following way. Sum plus I. Let me explain you this loop here in comment. Well, the goal is to compute the sum 1 plus 2 plus 3 plus 4 plus and so on plus, for example, 15. How we compute this sum? First, we compute 1 plus 2. After that, we add to this value the next number, 3, the next number, 4, and so on. Step by step, we change the value of the sum, and we compute, and on this this way we compute their total sum of these numbers. Let's output the result to the screen. Final sum equals to sum. Okay, let's run. And we will see that the sum of first 15 numbers is 120. If I modify this n, the sum of the first 5 numbers will be 15. If I want to output to the screen the intermediate sum, I can insert here cout statement inside the loop. And pay attention that we will see on the screen different values of sum on each loop iteration. Let's check it. The first value of sum is 1. Next value is 1 plus 2 that equals to 3. Next value is 3 plus 3 equals to 6. Then 6 plus 4 equals to 10, and so on. And the final sum is 15. Also, the result that we see on the screen will depend on where I place this output statement. If I place it before this computational statement, we will see the previous value of sum. The first value will be 0. Yeah, the sum is 0, and on the first iteration of loop, I output to the screen 0, and only after that I change the value of loop. I change the value of the sum. Well, let me remind you that this operation sum equals to sum plus I can be written in a short form, sum plus equals to I. Let's run. And we will see the same result on the screen. Well, this is an example how to compute the sum of the numbers. Well, let me modify this example. Here I compute the sum of the numbers 1, 2, 3, 4, 5. Let's consider the case that I want to compute the sum of the numbers that I enter from the keyboard. How to do it? In this case, these can be modified. This formula can be modified as follows: number 1 plus number 2 plus number 3 plus and so on plus number n. I don't know these numbers. These numbers must be entered from the keyboard. In this case, I should insert here. Sorry, first of all, I should introduce a new variable a that will correspond to some particular number. In the loop 4, I should enter the value of this value from the keyboard and add it to the sum. So now this loop will be repeat these two lines. I enter a number a from the keyboard and add it to the sum. Let's check. Well, the program waits for my input. 5 numbers, 1, 2, 3, 4, 5. Any numbers, and it computes their final sum. Well, I want to show you here one feature of loop for also. Suppose that I forget to write these brackets and I write this loop several times. Sorry, I write this loop in this way. What happens? What will we see at the value of sum on the screen?
Number aléatoire.
What? Sorry, I don't understand your answer.
Number no identified.
No identify? No. Well, suppose that I enter the numbers 1, 2, 3, 4, 5. And we will see on the screen that the final sum equals to 5. Okay, let me enter another numbers. 1, 3, 6, 4, 2. And now the final sum will equals 2. Why? Why we see this strange result? The explanation is very simple. According to the general scheme of the loop statement, body of loop consists of only one statement. Only one. And when I write loop in this way, only the first statement is considered to be included in the loop body. Only this statement is repeated, but this statement is computed only once outside of loop. That's why I will see on the screen the message that the final sum equals to the last number. Because I enter the last number, number 2, and only the value of the last number will be added to the sum. Well, from the point of view of compiler, this loop can be written even like this, and it will be okay. If I compile this program, I will see the message succeeded. But from the point of view of programmer, I ask you to write brackets always, because these figure brackets shows you exactly where loop body begins and when loop body ends. You will never make a mistake if you write figure brackets. But if you skip it, the program will be correct from the point of view of compiler. Compiler can compile this program, but the result will be not correct. Okay, let me let me come back to the example where we summing up all the numbers, sum plus I, right? Let's run it again. We will see the correct value of the final sum. even when you write one computational statement inside loop body, please write figure brackets. Okay. Now let's consider another important example, how to compute a product of several numbers. Let me declare another value, product. Before we consider this example, again, I want to stress that the initial value for the variable sum here must be 0. If you forget to write here the initial value, Visual Studio outputs you the mistake. But if you assign not 0, but some other initial value, for example, -10, you will see incorrect result on the screen. Final sum is 5, but it's not 5 because I assigned here wrong value. So if we need to compute the sum of several numbers, the initial value for the sum must be 0. If I want to compute the product of several numbers, the initial value for the product must be 1. Let's compute the product. I can insert here one more computational statement. Product multiply equals to I. And output another result, final product equals to product. Let's check. And we will see that the sum of first 5 numbers is 15, and the product is 120. Well, what we will see on the screen if I change the value of the loop counter, if I start this value from 0, the answer is very simple. The sum is not changed, but the product will be changed. I'm sorry for a minute. Wait a minute, please. Okay, let's continue. Well, if I change the loop counter, the initial value of the loop counter to 0, then the sum is not changed, but the product will be 0. Because if one value of if at least one number will be 0. All the product will be 0 too. The result will be 0. The sum is 15 and their product is 0. Okay, and maybe the last example that I want to show you. This example is written here in Visual Studio. We consider now this example, how to compute the sum. And now let's consider the example number 1. How to compute 2 in the power n, 2 power 10, for example, or 2 power 3 or 2 power 4. Okay, let's consider this task. How to compute 2 raised in the power n. What is this result? Is 2 times 2 times 2 times 2 and so on n times, right? What is 2 power n? Is 2 times 2 times 2 n times. Okay. Now let me delete these two values. Let me introduce one more variable. Let it be result. And how to compute this value. Let's assign initial value result to 1 and the value of the result equals to, let me write it in a full form. Result times 2. Res equals to res times 2. So I multiply the value of the result on 2 at any loop iteration. And let me output to the screen 2 power n. Let me output n also here. How to do it? 2 power n. Okay. 2 power n. Then the equal sign equals to result. Two power n equals to result. Let's check. First, let's assign n equals 2. What is the value? Oh, sorry, it should be start. I should start from 1. 2 power 2. 2 power 2 is 4. Let's check. Yes, we see this answer on the screen. 2 power 2 is 4. What is 2 power 3? 2 power 3 is 8. What is the value of 2 power n? Good programmer should remember this value.
1 gigabyte.
1 kilobyte.
Oh, 1 kilobyte.
Kilobyte. And what is this value? 1 kilobyte, 2 power n?
1048.
For 8? No.
24.
1024.
24.
2 power n is 1024. 1024. 2 power 10. 2 power 20 is 1 megabyte. 1 megabyte, 1 million, and so on. 48,000. 2 power 30 is 1 gigabyte. Well, and when we discuss about the ranges of representation of integer numbers, I told you that the largest number is 2 power 31. So if I try to compute 2 in the power 35, I will see some wrong result. The result is 0.
Maximum to 31.
Yes, 2 in the power 31 can be computed. Or even because 2 power 31 minus 1, sorry. Actually, 2 power 31 minus 1 is the largest number. 2 power 31 cannot be computed. Yes, you will see that 2 power 31, we see negative number. Of course, it's wrong. But 2 power 30, okay. 1 gigabyte. Well, this line can be modified as a res times 2. And we will see the same result on the screen. Well, these are examples, again, examples of loop where we know in advance the number of repetitions. This loop must be repeated, for example, 10 times, 20 times, 30 times, and so on. Let's consider some features of loop 4. I come back to this presentation. Of course, these features is not maybe you will use it just a few times, but it's important to understand how it works. Well, expression number 2, the expression number 2 is a logical expression that should have a logical result. This result must be true or false. Expression number 1 and expression number 2 can be some computational expressions. And some of this expression may be skipped. For example, I can move this assignment outside of loop. The result will be the same. Now, this first expression is considered to be empty. The expression is empty. But the semicolon here is obligatory. If I delete this semicolon, the loop will be incomplete and the compiler outputs a mistake. So I must put here a semicolon, but this statement can be moved outside of the loop. Okay, let me move it again back here. Then this statement also may be empty, but I must write here the loop counter. Well, let me write here the output statement. The out, and for example, okay, the value of res, the value of the variable res. Let me output here in the loop. what we will see on the screen? We will see the sequence of intermediate results. The powers of 2. 2, 4, 8, 16, 24, and so on. But here I move the changing of loop counter from this position to this position. It can be done. But what happens if I forget to write this statement? What do you think? What happens if I forget to write the statement that changes loop counter?
I think she will run just one time.
One time? Unfortunately, no, not one time, but infinity many number of times. Look, the value of I is 1. 1 smaller than 10. 1 is smaller than 10. Yes, the answer is yes. But value of I is never changed. I still be 1 and I still be 1 and this condition still be true always. 1 smaller than 10, true. 1 smaller than 10, true, and so on. So this loop will never terminate if I forget to write here loop counter. Let's check it. Yes, we will see this message on the screen. Loop never terminates. The program will work, and so on. I can only close this program. Okay, let me output to the screen not only the value of res, but also the value of loop counter. I equals to I, and after that res equals to res. Okay, and let me run the program again. We will see the we will see the result is 0 and the value of I is 1. 1 is smaller than 10 always. Well, I will show you another example, because here, when I write the statement that change loop counter, the loop will terminate. 1, 2, 3, 4, 5 up to 10. The next value of I is 11, 11 greater than 10, and the loop is stopped. Loop condition becomes false. What happens now? Suppose I write wrong statement that changes loop counter, not I++, but I minus minus. The first value of I is 1. The next value of I is 0. Next, -1, -2, -3. Also, these numbers will always smaller than 10. The loop will be endless again. Let's check it. Yes, we will see on the screen the large negative numbers. -4,000, 5,000. These numbers will always smaller than 10. So loop is never stops. I can only close this program. Okay. Now let me show you this example. What happens now? Suppose I assign I equals to 20. What will we see on the screen now? When I equals to 20.
Nothing, because I
Nothing.
not
Nothing. No. Again, no.
we have I большой than n.
Yes, I больше и больше, чем n. I is greater than n. It means that this loop will never execute, but we will see on the screen this line, the output of this line, that 2 power n, 2 power 10 equals to the first value of the result, equals to 1. We will see on the screen that 2 power 10 equals to 1. Well, okay. Usually, we write here some comparison as a loop condition. But here I can write any condition that I want. Moreover, I can write here some logical expression, some expression that has a logical value. The possible results of logical expressions are true and false. True and false also can be considered as the simplest logical expressions. So I can write this loop like this. For I equals 20 true I++. It means that this condition will be true always. And again, now this loop will be infinite. It will be endless loop. If I write here false, it means that the loop body will never be executed. Of course, I think on practice, on your practical tasks, you will never write such loops with such conditions like loop for with false. Of course, you should write here some comparison operation. It's a most convenient form of loop for. I show you this example just to indicate that, just to show all the possibilities of C language. How this loop can be written. What can we use here? Okay. And some additional slides with counters. We consider these examples in Visual Studio. I think I can skip it in my presentation because we'll discuss about it in details when I show you the examples in Visual Studio. Then loop while. Loop while we consider on the next lesson. Next week we discuss about loop while. We consider some examples related with loop while. We discuss about difference between while and for. Now our time is completely over. We have just a few minutes. If you have some questions about loops, you're welcome. You're welcome to ask me any questions.
No question, Professor. Thank you so much.
Well, if you don't have any questions, let me stop recording.